Welcome back to another video. So this is an organic chemistry video, which is part 2. On the first video I did functional groups and what are the different homologs and what does that mean. So functional group is an atom or a group of atoms that determine the chemistry of a molecule. So the functional group for all the homolog series must be identified from structural formula and name of organic molecules. So when you see a functional structure, you should be able to name the homolog series. And you can also know a homolog series by looking at the name that is given, and you'll be able to know if this is alkane, alkaline, haloalkane, and all the forth. So we have homologs, series, functional group, and general formulas. You have to know the N represent the amount of, in the general formula, carbons we have in a structure. So if you have 6 carbons, that will be C6, and then for every carbon there are 2 hydrogens or 3 hydrogens, right? Depending, the first one has 3 and the last one usually has 3 hydrogens if it's an alkane, alkenes. So you will just say 2 hydrogen for 6 carbons. So what you have in front of N would be the N on H. It means when you multiply 2 by that 6, that's the amount of hydrogens which you have. So let's move. Those are the homolog series. That's the table, the structure or functional group, name of functional group, and general formula, right? So we will do much of the general formula on the next video. And another thing you have to know is that you can do this worked example. A is the homolog series functional group, and you have to identify what it is. So you have to know what has what and what has what, because that's how you have to know. So make sure you watch my first video so that you will be able to know what everything means or what everything is. How do you identify them? So this is a worked example. You just look at the functional group and know if this is an ester, this is an alkaline, alkene, carboxylic acid, alkane, or haloalkane. So you will know all of that by looking at the functional group, whether it is a double bond oxygen and carbon, or a double bond carbon, or it just has carbon and oxygen. And another thing, those are examples, you can do them, and you need to know hydrocarbons. When you're talking about hydrocarbons, we are talking about molecules that have hydrogen and oxygen. So those are hydrocarbons, right? You only have hydrogen and carbon atoms only. Those are hydrocarbons. So it's the first 3 is you have alkane, alkene, I struggle to pronounce this word. It is the one that has alkane. Is it alkene with the Y? They have hydrogen and carbon. The second one has double bond carbon. The third one has triple bond carbon. And then you have to know difference between saturated and unsaturated hydrocarbons. By just looking at the structure, you can tell which homolog series each block belongs to. And then we have saturated and unsaturated hydrocarbons. So for the saturated one is the ones that only have HC with no double or triple bonds. So out of the hydrocarbons, the unsaturated is this one, alkaline, is the one that is unsaturated, and you have this one here. They contain covalent double bonds or triple bonds. A covalent bond, guys, it's a bond between two non-metals. So hydrogen is a non-metal, carbon is a non-metal. So when you bond them together and to form a molecule, they make a covalent bond. So the first three are alkanes. Others can have a mixture of covalent and ionic bonding, but this first three have covalent bonds. So whenever you see hydrogen or carbon, it's covalent, whether it's they have a double bond or a triple bond. So you can identify the following compounds as saturated or unsaturated and support your answer. There is the solution. You can test yourself. So in order for you to be able to name an organic molecule, you need to know this table. So in grade 12, the guideline says you have to know how to name a carbon atom that has up to 6 carbons. So that's what you have to know. And your parent chain, or the main chain, is carbons that are in a straight line. Like up here, these carbons, they are in the straight line. The first one, the second one that has 1 H, the third one has 1 H, the third one has 3 H's. So this one is a main chain, and this main chain can also have branches. And example of a branch, so this here is a branch. It's not part of the main series. This one here, it's the main chain. This one, it's the main chain. But that one on top, that is not part, and this one also, this is a branch, and this one also is also a branch. So you have to know when there is 1 carbon. Let's take this one for instance. There is 1, 2, 3, 4 carbons. So this will start with is for but. So it will the name will start with but, and then what you have to know, it's what this homolog series ends with. I think it's alkene, so it ends with ene. So that will be butene. It will be butene. Butene. It's butene, yes. So this is an alkene because it has a double bond carbon. That's how I know that is an alkene. So you just check by the number of carbons here, and then you will know. And then you look at the functional group to be able to know which homolog series is this one. I'll be doing a video where we will another video will be doing this. So the rules of naming organic molecules is that you identify the number of carbon atoms in the parent chain of the organic compound. The following prefixes will be used, and then the second step is that you number the carbon in the parent chain. So when you're naming them, start with the carbon at the end close to the functional group. Let's look at this for instance. But here we have 1, 2, the functional group is on the third carbon. When you are counting from the left, right, is on 1, 2, and 3, those 2 and 3. But when you're counting from the right, you will have it's on the second C. So you count your carbons from the end of the chain, where the end of the chain, the functional group is next to the end of the chain, either from the left hand side or from the right hand side. And then this will determine the suffix of the name. So the suffix of the name, these are homolog series, and this is what the name will end with. So the name will end with what we have here, and the name will start with whatever that is this side. This is how the name will start, depending on the number of carbons. So this is how the name will start, depending on the number of carbons that are present. And the name will end with this prefixes. So it will start with that one based on the number of carbons that are present, and then you look at the functional group, and the functional group will tell you what type of homolog series that structure is, and then you will know what it ends with. And now you can learn how to name the branches. So you have a bromo for haloalkane, chloro, fluoro, and the ones for ester. Now step 4, identify any. We just did step 3. We did step 3 where we have to check at the prefixes, and then now here you need to know, okay, this is a continuation there of the prefixes. And now step 4, identify any branched group, right? Name the branch group by counting the number of carbon atoms in the branch group. These groups will all end with ly, ig, methyl, ethyl. Note the position of the branch group on the main carbon chain. If there is more than one of the same type of branch group, then both numbers must be listed, 2 or 4. You name where the branch is. It's the branch on carbon number 2, the branch on carbon number 3, 4, 5, or whatever you name before the name. And then if the molecule is an alkane, the branch group must be on the carbon with the lowest possible number. So the branch group must be listed before the name of the chain is in alphabetical order. So the branch group must be listed before the name of the main chain in the alphabetical order. D, tree, tetra, right? For 1 branch, 2 branch, and 3 branches. Naming of alkanes. When naming alkanes, the halogen atoms do not get preference over alkyl groups. So when you're naming halogens, there are also steps to follow. And in table 12, you have summary of naming organic compounds. So the longest continuous carbon chain, prefix, suffix, and repeating substituent. So this is the breakdown. The following name that is on top there, 1.2 dibromobutane and propanol. So as you can see, that repeating substitute branch, we have 1, 2, and di. And then for the prefix, we have bromo, that is a prefix. And then the longest continuous chain is BUT, that's a number of, that's the number of carbons, how many carbons are there. And then the suffix, it ends with ane, so that is an alkane. And then propanol, repeating substitute, it doesn't have branches. The prefix, not there. The longest continuous chain, it has prop, that's the number of carbons there. And then the suffix is al, and al is aldehydes. Right, you know, all the saturated compounds consist of an before the suffix. Only alkenes, alkanes do not contain an. So, but the saturated ones do. Try to write down the IUPAC name for the following structure, and that is the solution. And then again, let's talk about isomers. What are isomers? Are organic molecules with the same number, with the same molecular formula, but with different structural formula. So type of isomers, we have chains isomers, have the same molecular formula, but different types of chains. So chains isomers, we have butane and methylpropane, and then we have, those are the explanations there, and those are the chain isomers. And then we also have position isomers, those are our 2 position isomers. And then we have positional isomers. What the name ends with will tell you what a homolog series that is. And this is the functional isomers. So you can test yourself with this table just to know whether you are able to know the functional groups for each homolog series and the general formula. And this one is the second test as well. You can test yourself now. If you, when you have a name, you can identify the answers. Thank you guys for watching this video. Until the next one, bye.